Greetings, Physics 109 students. So I'm making this video here to chat about problems 6 through 9 on your Unit 4 homework. Unit 4 over electricity or electrical phenomenon. So in number 6, let's see, it says a current of 0.4 amps. So what they're giving us is, the current as stated. In my example, it's 0.4 amps, but in yours it could be something else. It goes through an electric motor for 8 minutes, so that's a delta T. Now, in my example, they gave 8 minutes. That would be 480 seconds. And I'm doing that conversion because the unit of current is the amp. Well, an amp is a coulomb per second. So I'm doing that to make the units consistent. So now I'm just going to write this up. Current is delta Q over delta T. That's how it's calculated. And in my example, the current is 4 amps, or in other words, 4 coulombs per second. I'll write amps. Equals delta Q, I don't know, over delta T. The delta T is 480 seconds in my example. Right, in your folks' example, these will no doubt be different numbers. But it's just a matter now of multiplying both sides by the time, and you'll have the charge. Number 7 is virtually identical. They give you a current, they give you a time, ask for charge. So 6 and 7 are both done just like this. 8. Let's see, it says an 8 NC. Let me get a new picture here before we discuss it. All right, in number 8, it says an 8 and it says NC. Charge. Actually, mine says 8.01. Now let's talk about this N. This stands for nano, which means 10 to the minus 9th. So this 8.01 nanocoulombs, this means 8.01 times 10 to the minus 9th coulombs, is located 1.64 meters from a 4.46 nanocoulomb charge. So I've got another charge of 4.46 times 10 to the minus 9th coulombs. So I'm going to go ahead and draw these charges. I'm going to call this Q1. That's going to be this guy. And there's another charge that I'm going to call Q2, and that's going to be this guy. And then in my example, these are 1.64 meters apart. And it says to find the magnitude of the electrostatic force that one charge exerts on the other. So again, that's an example of the Coulomb force. Here's how it's calculated. Right, K, Q1, Q2 over distance squared. So the K is the Coulomb constant, 9 times 10 to the 9th Newton meter squared per Coulomb squared. And then you're going to use one of your charges for Q1, use the other charge for Q2, and then divide by your distance squared. Looks like all of the units are consistent. You're going to get a number out of it. All right, toughest part maybe will be working the calculator work. Just go through it very, very, very cautiously. All right, if you have any trouble with it, send me an email or something and I can help you out. And I'm going to talk a little bit about number 9. All right, 9. First of all, let me talk about the picture. I've got a picture on my sheet that looks something like this. There's 3 charges already there. Now, first of all, you got to realize what this symbol means. You notice, like it says, at least in my example, it says 6.00, and then there's this funny symbol, and then this Coulomb symbol. This means micro, and it means 10 to the minus 6. So this 6 microcoulombs means 6 times 10 to the minus 6 coulombs. Then in my example, this one is labeled 1.5 microcoulombs. And then the other one is minus 2 microcoulombs, which is minus 2 times 10 to the minus 6 coulombs. And again, in your folks' homework, these may be different values. But if they have the micro, that means 10 to the minus 6. All right. Again, in my example, this is listed as 3 centimeters. And this is listed as 2 centimeters. And it says, what is the magnitude and direction of the negative 2 microcoulomb force? All right, so in my example, what we're talking about is what is the force on this charge. Now, these 2 charges attract one another. and so do these. And so do these two. So there's going to be two forces acting on this particle. So I'm going to draw them both. Let's see, if I call this charge 1 and this charge 2 and maybe this charge 3, then I'm going to call this one F13 for the force created by charge 1 onto charge 3. This guy will also attract this charge, so that's going to pull it to the left as well. So I'm going to draw another force vector. I'm going to call that one F23 for the force from charge 2 onto charge 3. These forces are in the same direction, so they're going to add. So what we would call the net force is the sum of the two. So that's going to be force 1, 3 plus force 2, 3. Each of these forces are calculated using Coulomb's law. Right? So for example, this one is going to equal K times charge 1 times charge 3 over this distance squared. I'll just put d1 squared if you don't mind for that. So I'm calling this d1. In my example, that'd be 5 centimeters, which is 0.05 meters. So I'll just put that there. This would be 0.05 meters in this example. And then the Q1 would be 6 times 10 to the minus 6 coulombs. And the Q3, this is charge 3, is 2 times 10 to the minus 6 coulombs. You do not need the minus sign. And the reason you don't need it is this. When I drew these forces to the left, I've already used that minus sign. Remember why I drew them to the left? Because I said, okay, this is plus, this is minus, therefore it's an attractive force, and that's why that force is to the left, and same thing for the other pair. You don't need the minus sign in the calculation at all. Right. Force 2,3 is going to equal K Q2 Q3 over this distance squared. Oops, squared. Okay, so in this equation, again, this is the Coulomb constant, 9 times 10 to the 9th. My Q2 is this charge. In my example, that's 1.5 times 10 to the minus 6. My Q3 is this charge, 2 times 10 to the minus 6 coulombs. And then the distance, again, for the force between these two is 2 centimeters. Got to be careful, you want that in meters. That would be 0.02 meters. So that's where you put all the numbers in to get the net force on this particle. You know, it's not super important for you folks to be able to do calculations like this. I'm giving these examples just to give you some experience with the Coulomb force and how it's calculated. The more important thing really for you folks is conceptually understanding the force directions. Like in this example, why these are both to the left. Or for example, if I were to pick this charge, the two forces would be to the right because this guy will repel it and this guy attracts it. Right? Another important thing for you folks is understanding what happens to these forces when we change the distances and the charges. But anyway, for your homework, you know, your homework is designed to just give you some practice and some experience dealing with these forces. I hope this video is enough to get you through those problems, 6 through 9. I'll go ahead and make another video for 10 on. All right? Hope this helps. Have a great day.